Hi, hello, welcome to another math lesson. We're going to talk about structure, notation, and expression. A lot of this video is going to be vocabulary, so I'm going to try and kind of go quick through that. If you need a pause or anything, you're welcome to do that. Okay, here we go. And of course, it doesn't want to work. All right, we'll do it this way. Okay, so during this lesson, you will learn how to understand and interpret the different types of equations and expressions. So vocabulary is the base. The base is the number, variable, or expression that has a power or exponent. So right here in this case, my base is a 2, right? So there's the base. My exponent is the power that is raised from the base. We see it right there. A variable is any letter in an expression that represents one or more numbers. A factor is a number that can be divided out of another number. So like say I have 6. My factors of 6 are 2 and 3. I can divide those numbers out. A factorization is 2 or more numbers that multiply together to another. So a factorization of 6 is 2 or 3. A term is terms are single numbers, variables, or a combination of both that are separated by pluses and minuses. So if I have like 3x plus 4, I have 2 terms. Terms can contain exponents, so I could have like 3x squared, and it would still be a term. Okay, so a polynomial is a function or expression that consists of many terms, so something like this, 3x to the 4th plus 2x third minus 3x squared plus 2x minus 5. That would be a polynomial. A monomial is a polynomial of one term. A binomial is just a polynomial with 2 terms. Trinomial with 3 terms. If I have a coefficient number in front of a variable or the number multiplying the variable, every term has one coefficient. Remember, if there's no number in front of the letter, it is assumed that the coefficient is 1. If I have something like this, 3x squared plus x, my coefficients would be a 3 in front of that first term. There's nothing here, which means it's a 1. Alright, an expression are numbers, variables, and operations, plus, minus, multiply, divide, that are put together to form a phrase. Expressions do not have to have an equal sign. A linear expression is an expression in which the variable has no exponent. So we would think of this as something like y equals mx plus b. Notice there's no exponent. An exponential expression is an expression in which the variable is the exponent. So y equals a raised to the x power. So notice my a would be my base, and my x, which is my variable, is in the exponent. Next, my quadratic expression is an expression that consists of terms in which the highest degree is a 2. So highest degree, that's talking about an exponent. So it'd be something like this. 3x squared minus 4x plus 3. So let's notice something here. I have an exponent here, degree 2. I technically have an exponent here, it's just a 1. And there, my exponent's a 1. So my highest degree, or my highest exponent, is a 2. Okay, that tells me it's quadratic. So let's look at this. Quadratic expressions. Which ones have highest degree of 2? Well, I have a degree of 2 here, degree of 2 here. So I know my quadratics are both of those. Exponential expression is looking for my x, my variable, in the exponent. My variable's in the exponent right there. So we're good there. Then my linear expression has my highest exponent of 1, so we're never going to write it. So it's right there. Okay, y equals mx plus b. It's that linear line. Okay, so math operations. So we have multiplication, division, addition, and subtraction. So there are multiple ways these operations can be represented and how we talk about them. We can use parentheses, are oftentimes used to show operations. Okay, we often use parentheses to show different forms of multiplication or to separate multiplication from addition. So here's some key words. The sum is the result of addition. The difference is the result of subtraction. Product is the result of multiplication. And quotient is the result of division. Okay, so we have addition, subtraction, multiplication, and division. There we go. Okay, so we're going to practice writing some expressions here. We're going to give you some word problems, and then we're going to try and piece them together. So write the mathematical expression of the sentence below. The area of a rectangular field if one side is length x and one side is length 2. So I'm looking for area when one side is length x and one side is length 2. So I'm going to draw this picture out. Anytime we can, we're going to draw a picture. One side is length x, one side is length 2. Well, I know that area is equal to the length multiplied by the width. So my area is equal to 2x. Alright? Alright, so we're buying 4 apples. Okay. Doing the same thing. We'll do this for a couple times. We have 4 apples and they are $M each, and 7 bananas are $N each. Write an expression to represent the total amount of money. Okay, so let's just define some stuff here, okay? So we know that M equals cost of apples, right? We know that N here equals the cost of the bananas. So my total, okay, my total is equal to 4 apples multiplied by $M plus 7 bananas. Oh, we don't have a B. There's no B in here. We have 7 bananas that are multiplied by $N. Right, so if I have 4 of them, I have to pay that 4 times. That's multiplication. Same thing with my 7 bananas. Alright, so we split 11 slices of bread between Y people. Okay, so think of it. I have 11 slices of bread and I need to split it evenly. Write an expression. How would I do that? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 people. I have 11 slices of bread and I don't know how many people. So what we're going to do is we're going to take my 11 slices, and it gets, whenever we see that between, we're thinking of some division here by Y people. 11 people, or 11 slices divided by Y. Okay? Alright. Next, you give a card to 2 people and ask them to each give cards to 2 more people. Write an expression to represent how many people receive cards. Write an expression to represent the situation if it continued on X amount of times. When X equals 1, you gave the card to 2 people. When X equals 2, those 2 people both pass them on to 2 more people. So let's kind of just draw this out. So I have a card, right? And I pass it to 2 more people. So this is at 1, this is 2, and then that person passes it to 2 more people. That person passes it to 2 more people. So there's 3. It's going to go so on. So what I would do here is I would make a table to kind of see what's happening. So on 1 I have 1. On 2 I have 2. On 3 I have 4. If you need to keep seeing the pattern, you can keep drawing this out. right? 1, 2, 3, 4, 5, 6, 7, 8. The fourth one, I have 8. So what am I doing each time here? I'm not adding the same number each time, because here I'm adding 1, and then I'm adding 2, then I'm adding 4, I'm adding 1, and then adding 2. So we know it's not linear or quadratic. Alright. But what I am doing is I'm multiplying by 2 each time. So we know it's exponential. So this is that equation of y equals f is 0 plus, or not f is, not plus, f is 0 multiplied by my common ratio, which is 2 raised to the x. But I just need my f is 0 now. So this would be 1/2. Because my f is 0, I'd have to go one more this way. So I'd divide 1 by 2, right? So you get 1/2 times 2 raised to the x power. And that would give you your expression. Alright, Mama May has a cow farm with 26 cows. She wanted more cows to fill her field. She went to the cow salesman, Farmer Joe, who had 217 cows, and Mama May that's a weird written sentence, I'm sorry. Farmer Joe had 217 cows and Mama May now has. Write an expression to show how many cows Farmer Joe now has. So it's kind of weird. This 26 cows kind of is throwing us off because we don't care how many cows Mama May has. We're asked how many cows does Farmer Joe have after Mama May gets some cows. So let's say C equals number of cows sold. Okay, so we would say starts with 217. We subtract so many cows, and that would equal, if we say this is Mama May's 20, well, that actually we don't need to do that. It'd just be 217 minus C because we're just taking away cows from Farmer Joe. Alright, that's the last slide. If you guys have any questions, please feel free to come and talk to me or a tutor, and we'd be happy to help you. Have a great day. Thank you.